Evaluate the piecewise-defined function for the indicated values, then sketch its graph. F of x equals 3x for x is less than or equal to 0, x plus 1 for x is greater than 0 and less than or equal to 2, and x minus 2 squared for x is greater than 0. Let's make a table of values, and let's look at each of these separate parts of the domain on its own. So the values we're asked to deal with are -5, 0, 1, 2, 3, 4, and 5. Now, the first part of the domain is x is less than or equal to 0. So that's going to be these first two values. Then we've got x is greater than 0, but less than or equal to 2. That's going to be the next two values. And then finally, we have this third domain, which is for all of the values greater than 2. So let's plug these in. For the first domain, we have f of x equals 3x. So 3 times -5 will be -15, and 3 times 0 is 0. For the next domain, we've got x plus 1. So 1 plus 1 is 2, and then 2 plus 1 is 3. And then the third domain is a little bit more complicated. We've got x minus 2 quantity squared. So 3 minus 2 is 1, and 1 squared is 1. 4 minus 2 is 2, and 2 squared is 4. And then 5 minus 2 is 3, and 3 squared is 9. So we've got our values. Let's go and plot them and try to see what this graph is going to look like. All right, so for the first part of the domain, we're looking at x is less than or equal to 0. So we're looking at the left-hand side of the graph, and we have the points -5, -15, and 0, 0. Unfortunately, -5, -15 is outside the range of this template that we have, so we can only really plot 0, 0, but we can pick some other points to try and make this work out. So for x is less than or equal to 0, we could also pick -1 and -2. Oops. Now, if we take -1 and multiply it by 3, we get -3. If we take -2 and multiply it by 3, we get -6. And that gives us two other points that we can plot. And we know that this is a linear function, and it's linear all the way up to 0 and to the left of it, so we can connect the dots, drawing a ray. A ray is a line that only extends in one direction for there. Now we can look at the second part of the domain. We're looking between 0 and 2. So if we look at these 2 points that we have 1, 2 and 2, 3. Again, we have a linear function. It's just a different linear function. Instead of 3x, it's x plus 1. So what we can do is we can connect these with a line segment, and we know that this is going to be the case between x equals 0 and 2, so we can continue this all the way until we get to x equals 0, but we need an open circle here because 0 is not a part of this middle domain. So that's the second part of the graph. The third part of the graph, x minus 2 squared, that is a quadratic expression, so we're going to end up with some sort of a piece of a parabola. We can plot those last points, 3, 1, 4, 4, and 5, 9. Now we know that this is going to be a piece of a parabola, and we're going all the way to the right, but this is only valid for x is greater than 2. So we need to go all the way to 2 here, and we don't know if it's going to keep going down, if it's going to go back up, etc. So here's what I want to do. We know that the end point is going to be at x equals 2. It's just going to be an open circle. So what I want to do is I want to evaluate this when x equals 2. When x equals 2, we've got 2 minus 2, which is 0, and 0 squared is 0. So the end point of this piece of a parabola is going to be at the point 2 comma 0, but it's going to be an open circle because it's not included in that part of the domain. So it's not included on the graph. It's going to end up being our end point, but it's not actually a closed circle. It's not actually part of the graph. So this is an example of how we could evaluate a piecewise defined function for several values and then use those to figure out what the graph looks like. Again, we're not going to look at too many examples of piecewise defined functions in this class. I just wanted to show you a few so that you can get a little bit comfortable with what they look like and how they operate.